Tonight, if you step outside and find the constellation Orion, look at his right shoulder, the bright point at the upper left of the Great Hunter, and you will find a star burning a deep, restless orange. Its name is Betelgeuse, and right now, as you look at it, it is fading. Not in some distant, abstract sense. Tonight, this week, Betelgeuse is the faintest it has been in 2 years, and the astronomers who have spent their whole careers watching it are asking the same uneasy question they asked once before. Is this the beginning of something? Because the last time this star behaved this way, much of the world quietly believed it was about to watch a star die. For more than 4 centuries, we have charted Betelgeuse swelling and dimming and flaring back to life. And in all that time, we have never truly understood why it is so restless. And then, a telescope on a mountaintop in Hawaii looked straight into its glare and found something hiding inside the light. Because Betelgeuse, we now know, has never been flickering alone. Something has been moving through it the entire time. And while the world argues about whether the star is dying, almost no one is looking at the thing standing right beside it. To understand why a single fading star can unsettle professional astronomers, you have to understand what Betelgeuse actually is. It is not a star like our Sun. It is a red supergiant, one of the largest stars visible to the naked eye anywhere in our sky. And it is colossal in a way that is genuinely difficult to hold in the mind. If you could lift our Sun out of the center of the solar system and set Betelgeuse down in its place, the surface of the star would swallow Mercury, then Venus, then Earth, then Mars. It would engulf the asteroid belt entirely. Its outer edge would reach out toward the orbit of Jupiter. Everything we think of as home, every world we have ever stood on, every planet we have ever sent a spacecraft to visit, would simply be inside the star. And that surface is nothing like the calm yellow face of our Sun. Betelgeuse boils. Where the Sun's surface is stippled with millions of small churning cells, Betelgeuse heaves with just a handful of titanic ones, each one larger across than the orbit of the Earth. Vast plumes of star stuff, rising, cooling, and sinking again, slow and colossal. It is this restless, lopsided boiling that makes the star flicker, and that, now and then, flings a piece of itself out into space. And yet, for all that size, Betelgeuse is not old in years. It is young, and it is dying anyway. A star that vast burns through its fuel at a furious, unsustainable rate. Betelgeuse is only around 10 million years old, an infant beside our middle-aged Sun, and it is already in the final chapter of its life. It has fused the hydrogen in its core, then the helium, and now it works its way down through the heavier elements toward an ending that, for a star this large, can only arrive one way. Look at Betelgeuse on 2 different nights, weeks apart, and you may notice it has changed. It brightens and dims on a rhythm that has fascinated observers since at least the time of John Herschel, who recorded its wanderings back in the 1830s. It is what astronomers call a variable star, and generations of amateur observers around the world have logged its brightness night after night, building a record that reaches back further than almost any other stars. There is something quietly unnerving about a star that changes at all. We are taught that the night sky is the one fixed thing, that the stars our ancestors looked up at are the same stars we see, unaltered, eternal. Betelgeuse breaks that promise. Its very name, worn down over the centuries into something we no longer quite understand, comes from an old Arabic phrase for the hand or the shoulder of the giant. A star so prominent that almost every culture that ever looked up gave it a place in its stories. And it has been quietly misbehaving the entire time. But that record held a puzzle. Betelgeuse does not pulse on a single clean beat. There is a faster rhythm of roughly a year or so, the star physically swelling and shrinking, breathing in and out. And layered on top of it, a second, slower cycle that takes around 6 years to complete. The fast pulse astronomers could explain, slow 6-year rhythm they could not. For decades it simply sat there in the data, unexplained, a heartbeat with no obvious source. Hold on to that 6-year rhythm. It matters more than anyone realised. Then came the winter that frightened everyone. In late 2019, Betelgeuse began to dim, and it did not stop. Through December, into January, into February of 2020, the star kept dropping, until it had lost so much of its light that you could see the difference with your naked eye. Orion's shoulder, a fixed point for the whole of human history, visibly faded. At the depths of it, the star had shed a startling fraction of its brightness, by some measures close to 2/3, and the astronomical world held its breath. Because a massive star that suddenly dims is, in theory, exactly what you might expect to see in the last act before a supernova. Telescopes across the world and above it turned toward Orion. For a few weeks in early 2020, a real and serious question hung in the air. Were we about to watch Betelgeuse explode? Was this the death so many astronomers had waited a lifetime to witness? The event even earned a name, the Great Dimming. And then, slowly, through the spring of 2020, the star brightened again, climbing back to its old self as though nothing had happened. Whatever it had not been the end. But it would take a new image, a direct look at the star's own surface, to understand what it actually was. When astronomers led by Miguel Montages turned the Very Large Telescope in Chile onto Betelgeuse during the dimming, they captured something remarkable. A direct image of the star's surface, blotchy and uneven, with a great dark region spreading across its lower half. The star had not faded uniformly. A whole portion of it had gone dark. And the explanation, when it came, was almost mundane next to the fear it had caused. Betelgeuse had belched. A vast cloud of gas had been flung off the star's surface, a surface mass ejection, and as it drifted outward and cooled, it condensed into dust. A dark veil of the star's own making, hanging between Betelgeuse and us, dimming it from our point of view. Not a death rattle, a cough. The star had not been dying in 2020, It had been shedding a piece of itself, the way these restless giants do. The panic faded along with the dust, and for a few quiet years, Betelgeuse was simply Betelgeuse again, until it started to fade once more. Because since the beginning of 2026, the star has begun to dim again, and this time it has slipped to its faintest in 2 years. Observers are watching it closely, comparing it night by night against the steady stars around it, and the old question has surfaced with it. Is this another ordinary dip, or the start of something larger? It would be easy, and it would earn a great many clicks, to tell you that this is the countdown at last, that the star is finally going. But the honest answer is stranger and more interesting than that, and it begins with the thing that telescope in Hawaii found hiding in the glare. Because the real story of Betelgeuse turned out not to be about how it dies. It was about what has been keeping it company all along. For years, astronomers had effectively split into 2 camps over this star, and the unsettling part is that both are reading the very same evidence. One camp sees a star that is restless but not imminently doomed. Its dimming explained by dust, by its natural pulsing, and, as we are about to see, by a companion. On this view, Betelgeuse is many thousands of years from its end, and every dip is just the star being itself. The other camp looks at the same star and sees something far closer to the edge than the textbooks say. In 2023, one group of researchers argued that Betelgeuse may already have finished burning the helium in its core and moved on to carbon, a late, fast-burning stage that would place the supernova not in 100,000 years, but potentially within mere centuries, even decades. Same star, same data. 2 readings separated by 100,000 years. We will come back to who is most likely right, but first we have to meet the companion. In December of 2024, the Gemini North telescope, high on Mauna Kea in Hawaii, did something that had defeated astronomers for a century. It resolved a second point of light, buried deep inside Betelgeuse's overwhelming glare. A faint companion star, orbiting so close that it sits within the giant's own bloated outer atmosphere. People had suspected for years that something must be there. The fingerprints were in that unexplained 6-year rhythm, the slow heartbeat no one could source. But suspecting a companion and actually seeing one against the blaze of a star tens of thousands of times brighter are very different things. Gemini North caught it. Catching it at all was a feat. Betelgeuse outshines its little companion by tens of thousands of times. And from our distance, the 2 are separated by a gap so small it had swallowed every previous attempt to tell them apart. It took the sharpest modern instruments and a technique for freezing out the blur of our own atmosphere to finally tease that faint second light out from underneath the glare of the first. And in 2025, the International Astronomical Union gave the companion a name, Siwarha, from the Arabic for her bracelet, a quiet echo of Betelgeuse's own ancient name. Astronomers, more affectionately, took to calling it Beetle Buddy. a second star, hidden in the light of the first for the whole of recorded history, finally pulled out of the glare. And what it turned out to be was not what anyone had expected. The natural assumption when you find a companion orbiting an ancient dying giant is that it will be something equally old, perhaps a white dwarf, the burnt-out cinder of a star that died long ago, a corpse circling a corpse to be. Siwarha is nothing of the sort. It is young. It is small, roughly the mass of our own sun, give or take. A star that has barely begun its life, circling one that is nearly at the end of its. A newborn and a dying giant locked together. And Siwarha's situation is precarious in a way that is almost poignant. It orbits so deep inside Betelgeuse's tenuous outer layers that the giant's atmosphere is constantly dragging at it. Which means Siwarha is doomed, not by anything it has done, but simply by where it happened to be born. Over the coming thousands of years, that drag will pull it inward, tighter and tighter, until Betelgeuse swallows its small companion whole. The bracelet, in the end, is drawn into the star it adorns. But before that ending, Siwarha left a trace we could finally catch. In January of 2026, astronomers using the Hubble Space Telescope, led by Andrea Dupree of the Harvard-Smithsonian Center for Astrophysics, detected something extraordinary: the companion's wake. As Siwarha plows through the outer atmosphere of Betelgeuse, it drags a trail of gas behind it, the way a boat leaves a wake spreading across still water. And the timing of that wake, sweeping through the giant's atmosphere, lined up precisely with the orbit of the companion, the same roughly 6-year beat. The mysterious slow rhythm that had sat unexplained in the data for decades suddenly had an author. It was not the star alone breathing. It was a second star, carving its path through the first, over and over, once every 6 years. A century of puzzlement, resolved by a hidden companion that no one had ever been able to see. It was a genuine piece of detective work. For decades, that 6-year rhythm had been treated as a quirk of the star itself, some deep, slow pulse buried in its layers. The companion rewrote it. The star was not throbbing on that long beat at all. It was being stirred, on schedule, by something orbiting through it. The clue had been sitting in plain sight in a century of brightness measurements, waiting for someone to realize it was not a heartbeat. It was a footprint. And there is a small, almost theatrical detail to it. Siwarha is, right now, swinging around behind Betelgeuse from our point of view, lost again in the glare, and it is due to reappear in 2027. A doomed little star, briefly hidden behind the giant that will one day consume it, with a date already marked for its return. Which leaves the one question the companion cannot answer, the one everyone really wants answered. Betelgeuse will explode. That much is not in doubt. A star this massive has only one way to end. When it finally exhausts the fuel at its core, the center collapses in a fraction of a second, and the star detonates as a supernova, briefly outshining whole galaxies. It is worth pausing on what that detonation actually forges. In its final stages, a star like Betelgeuse builds an onion of heavier and heavier elements, burning carbon, then neon, then oxygen, then silicon, each stage faster than the last, the very final silicon burning lasting not millennia, but a single day. And in the explosion that follows, the star scatters those elements across space. The calcium in your bones, the iron in your blood, the oxygen filling your lungs right now were all forged inside and flung outward by dying stars like this one. Betelgeuse is not only an ending, it is the kind of furnace that made us. When it happens, Betelgeuse will become, for a few weeks, the brightest star our species has ever seen. It will blaze in full daylight. It will cast shadows at night. It will hang in Orion's shoulder like a second, smaller sun, and then slowly fade over months until the great hunter is left forever missing his shoulder. Every human being alive will look up at the same impossible light. The only question is when. And here is where honesty matters more than drama. The overwhelming consensus among astronomers is that Betelgeuse is not about to explode in any sense that should worry you. The best estimates place its supernova somewhere within the next 100,000 years, a blink in cosmic terms, but on a human scale, effectively forever. The dimming you can see tonight is not a fuse burning down. It is dust and pulsation and a small star carving its wake. That 2023 paper, the one arguing the core had already moved on to carbon burning and that the end could come within centuries or even decades, is real and it is worth taking seriously. But it is a minority view, one reading among many, and most of the field does not share its conclusion. It could be right, it almost certainly is not. The truthful answer to when will Betelgeuse explode is the one no documentary likes to give. We do not know. Probably not in our lifetimes, but we cannot be certain. And if you are wondering whether we are in any danger, we are not. Betelgeuse sits around 650 light-years away. A supernova would have to be far closer than that, within roughly 150 light-years, before its radiation could seriously threaten life on Earth. Betelgeuse is comfortably, reassuringly outside that line. So when it does finally go, tonight or 1,000 centuries from now, it will not be a catastrophe. It will be the single most spectacular thing any human has ever witnessed in the night sky, and it will be perfectly, completely safe. A star bright enough to read by, burning silently in the dark, harming nothing at all. The fear, it turns out, was never quite the right response to Betelgeuse. Or was. And it would be a spectacle unlike anything in recorded history. For the first few hours, the only sign would be invisible, a burst of ghostly particles called neutrinos pouring out of the collapsing core and passing straight through the Earth. Detectors buried deep underground would catch them and sound the alarm, and for a few short hours we would know that Betelgeuse had died before its light had even reached us. Then the light would arrive. Over a matter of days, that familiar orange point in Orion would swell into a blaze rivaling the half-moon, bright enough to see in broad daylight, bright enough to throw faint shadows on the ground at night. It would hold there for weeks, then slowly dim across the following months, until at last it slipped from naked eye view altogether and Orion was left forever with one shoulder missing. And it would be the closest, brightest supernova that humanity has ever knowingly witnessed. The last time our own galaxy gave us one bright enough to study with the naked eye was in 1604, Kepler's star, before the telescope had even been pointed at the heavens. The one before that, in 1054, blazed in full daylight for over 3 weeks and left behind the wreckage we now call the Crab Nebula. Betelgeuse would be closer than either and brighter than either, a front row seat for everyone alive to the death of a star. Though there is one last piece of vertigo to sit with. Betelgeuse is 650 light-years away, which means the light landing in your eyes tonight left the star around the year 1370. You are not seeing Betelgeuse as it is. You are seeing it as it was 6.5 centuries ago when that light first set out toward you. Which means the question, "Is Betelgeuse about to explode?" hides a far stranger one. For all we know, Betelgeuse has already exploded. The star could have died a century ago or two, and the light of its death could be crossing the dark toward us at this very moment, still years from arrival. The orange star you can see tonight is, in a sense, a ghost, a message from a past we have no way to update, sent by a star we will only ever know with a 600-year delay. But strip away the fear, and what Betelgeuse truly offers us is not a countdown. It is a gift. For the first time in human history, we have the instruments to watch a giant star actually live, to see dark patches bloom and fade across its surface, to watch it cough out dust, to track a hidden companion ploughing through its atmosphere in something close to real time. Betelgeuse is the nearest red supergiant to Earth, which makes it the one dying star of its kind we can study not as a distant point of light, but almost as a world, with weather and seasons and a companion of its own. Every dip in its brightness, every flare, every wake is a page in a textbook we are only just learning to read. A star's final chapter, unfolding slowly enough that we can actually watch the pages turn. It is not an omen. It is a laboratory the size of the inner solar system, hanging in our own sky. Every technique we sharpen on Betelgeuse, every method for imaging a churning surface, for weighing a hidden companion, for reading the chemistry of a dying star's breath, we will one day turn on the thousands of other supergiants too distant to resolve. Betelgeuse is simply close enough to teach us how to look. It is the rehearsal for understanding how the largest stars in the universe live and how they end. And so we are left where these stories always seem to leave us. A species on a small, wet, rocky world, standing out in the cold and looking up at a single fading point of orange light. Light that left its source 600 years before any of us were born, and arguing with telescopes and mathematics and a century of patient records about whether it is dying. It is not dying tonight. Almost certainly not in your lifetime, nor your children's, nor theirs. Betelgeuse will most likely go on dimming and brightening and breathing for longer than our entire civilization has existed so far, its small, doomed companion tracing slow circles through its atmosphere, on and on, long after everyone who ever wondered about it is gone. But one night, And it could be any night, tonight or 100,000 years from now. The light of its ending will finally reach us. Orion will lose his shoulder, and for a few weeks, Earth will have a second star, bright enough to read by, hanging in the dark. The sky feels permanent. It only feels that way because our lives are short. We simply happen to be alive in the brief window when Betelgeuse is still there to look at. So the next clear night, step outside, find Orion's shoulder, and look at it while you can. You are watching a giant breathe, and you are among the last few generations who will ever get the chance.